1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground. Today, still wanted by the government, they survive as soldiers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire
Mr. Moore! Guys, and welcome to Mr. Moore's online flipped classroom, and like always I'm extremely excited to be with you guys today because we're going to look at a thing called logarithms. Now, as you know, in previous lessons we've been looking at exponential functions and indices and index laws and all those types of things. And what I want you to recognize is that logarithms, whilst they're different, they are very closely related to indices. So let's have a look now at an animation on how we can transform an indicial equation into a logarithmic equation. So let's check that out.
Up until now, we have worked with indicial equations that have looked like this. That is, a has been the base, x was the power, and y has been the answer. Now, when working with logarithms, we can also label an index equation where a is still the base, but x is now known as the logarithm, and y is the base numeral. Now, why does this change things, you ask? Well, it's because as soon as we look at this equation as also being a logarithm, we can convert it from being an indicial equation into a logarithmic equation quite easily. And this will help us in later lessons when we are required to solve both indicial and logarithmic equations. Now, converting between the two equations is simple. To go from an indicial equation to a logarithmic equation, we simply swap the position of x and y and write log out the front of the a. Note the positioning of the a and the y have changed a little bit as well. The a has now been written as subscript, bringing the y down in line to where you've written log. Watch it once again now. The x and the y swap spots. Move the a and the y down and write log out the front. Going backwards now, that is converting from a logarithmic equation to an indicial equation, we swap the y and the x once again, and we move the a and the x up so that the x now becomes a power and is written in superscript. So as you can see from this formula, we can convert a to the power of x is equal to y into log base a to the y is equal to x with ease. And we can also convert back from a logarithmic equation into an indicial equation if required.
Awesome, so we've just had a look at how to convert indicial equations into logarithmic equations. So I guess maybe it's now time to go through and have a look at a couple of worked examples on how to actually apply this to some mathematical questions. Let's check it out.
So as you've just seen in previous lessons, we've been learning all about index laws and exponential equations. Now what we're going to do is have a look at the same kind of thing, but from a logarithms point of view. Now, as you've just seen in the little bit of the animation that you've just watched, we still call the a the base in this case, but we call the x the logarithm and the y value here, or whatever it's equal to, the base numeral. And we now know as well that we can transform a to the power of x equals y into a logarithmic equation, that is log ay is equal to x. So we say that this form here is its indicial form, and we say that this form here is written in its logarithmic form. So what we're going to do is have a look at how these actually help when exploring how to simplify logarithms. And to do that, we're going to evaluate each of the following without using a calculator. So we're going to look here at this log base 6 to 216, and what we need to do is we're going to rewrite this as being log base 6 to 216 is equal to x, like you can see here, because that's what we're looking for, is this x. So to do this now, what we need to do is rewrite it back in its indicial form. So to do that, we're going to swap over the 216 and the x and get rid of the log. So you're going to be left with 6 to the power of x is equal to 216, because as you can see, I got rid of the log and swapped over the positions of the 216 and the x. So what I need to think of is this 216. If I wrote this with a base of 6, 6 to the power of what gets me 216? Well, it's going to be 6 to the power of x is equal to 6 to the power of 3. So therefore I can rewrite that out as x is equal to 3 because I can get rid of these bases here. Now for this one here where I've got log 2 to the 1/8, I'm going to rewrite that as being log base 2 of 1/8 is equal to x. Now in order to be able to solve this, I need to rewrite it in its indicial form. So to do that, I'm going to get rid of the log and I'm going to swap over the placing of the 1/8 of the x. So it's going to be 2 to the power of x is equal to 1/8. Now 2 to the power of what will give us 1/8? Well, it's going to be 2 to the power of x is the same as saying 1 over 2 to the power of 3, isn't it? So therefore 2 to the power of x is going to be 2 to the power of negative 3. So when I get rid of the bases or equate the bases, I'm just going to be left with x is equal to negative 3. So as you can see, I can simplify logs by just transforming them into their indicial forms. So it's time now to press pause and attempt the following questions. That is, evaluate each of the following without using a calculator. For example, in A, log 4 to the 64, and B, log base 3 to the 4th root of 9. Remember, when you're done, to press play so you can check your answers out against mine. Alright, so welcome back. Now, as you can see, I've done log base 4 to 64, and in this example, what I've done is I've made it all equal to x, because that's what we're looking for. Now, in order to do this, what I need to do was transform it into its indicial form. So to do that, I need to swap over the 64 and the x, and then get rid of the log. So you get 4 to the power of x is equal to 64. Now, in order to rewrite 64, well, I know that 4 to the power of 3 equals 64, so I can rewrite it as 4 to the power of x is equal to 4 to the power of 3. Now, I don't need to have these bases here anymore, so I can equate the powers, so therefore x is equal to 3. Now, for this one here, I've got log base 3 to the quartic root of 9, so therefore I need to do log base 3 to the quartic root of 9 is equal to x, because that's once again what I'm looking for. And now I need to transform it into its indicial form, so get rid of the log. And now what I need to do is swap over your 4 root 9 and your x. So you end up getting 3 to the power of x is equal to quartic root of 9. So now I can rewrite out the quartic root of 9 as being 9 to the power of 1/4. And therefore I've got 3 to the power of x is equal to 9 to the power of 1/4. Now I still don't have it as the same base, so what I need to do is make 3 to the power of x equal 3 squared, because 9 is saying 3 squared, in brackets to the power of 1/4. Now I multiply the bases, so that gets me 3 to the power of 2 times 1/4, well, it's going to be 3 to the power of 2/4, is of course equal to 3 to the power of x. Now 2/4 simplifies down to get us 1/4, so you get 3 to the power of x is equal to 3 to the power of 1/2. Now we can get rid of the bases once again, leaving us with x is equal to 1/2.
Alright guys, so just like
The Big 8
index laws, there are 5 logarithm laws that we need to learn as well. Now, just because they don't actually have the same exciting introduction as the index laws doesn't mean they're not as important to learn. In fact, they are equally important and equally as exciting as the index laws. So let's now check out how to work with log law number 1.
Now log law number 1 states that if you've got log base a m times n, that's equal to log base a to m plus log base a to n, where m, n and a must all be greater than 0, but a cannot equal 1. So what does this mean? Well, if I've got log base 10, 5 plus log base 10, 4, what I can just simplify this as is log base 10 bracket 5 times 4. So what I do is I get the 5 and the 4 and I multiply them because these 10s here are the same. So therefore, log base 10 and 5 times 4 is 20, and that's how you can simplify that one. Now what I want you to do is press pause and attempt the following questions. That is log base 4, 5 plus log base 4, 2, and for part B, log base 2, 3 plus log base 5, 9 plus log base 5, 6 plus log base 2, 7. Remember, when you're going through and simplifying using the log law number 1, you can only combine logs that have the same base. And of course, like always, make sure you press play when you're done so you can check your solutions against mine. Alright, so welcome back. Now the very first thing you have to do when checking out these logs and seeing if we can actually add them is to have a look here and see if the bases are the same. So as you can see here, I've got 4 and 4, so that means we can actually add these two logs. Now in order to do that, we just write log base 4 and we multiply the 5 times 2 because you get the 5 and the 2 from here. So you go 5 times 2 is 10, leaving us with an answer of log base 4 to 10. Now for this one, part B, you've got log base 2, 3 plus log base 5, 9 plus log base 5, 6 plus log base 2, 7. What I've done is I've just rearranged everything here to put all of the logs with the same bases right next to each other. So as you can see here, I've got my 2 and my 2 at the end, and I've got my 5 and my 5 here. So I've just moved this one over to this end here, as you can see. So you get log base 2, 3 plus log base 2, 7 plus log base 5, 9 plus log base 5, 6. Now as you can see, I've got my 2 and my 2 together, so I just do log base 2 3 times 7 and log base 5 9 times 6, as you can see here, because my 5s and 5s are right next to each other as well. So log base 2 3 times 7, well 3 times 7 is 21, and 9 times 6 is 54, so you end up with an answer of log base 2 21 plus log base 5 54, and you cannot combine these because the bases are different, as you can see here.
Alright, so we've just had a look at how to add logarithms. Why not learn now how to subtract them as well? That's right guys, introducing log law number 2.
Now log law 2 states that if you've got log base a to the m over n, that's equal to log base a m minus log base a n, where m, n and a must all be greater than 0, but a cannot be equal to 1. So let's have a look at this in a worked example kind of form. If you've got log base 2 to 9 minus log base 2 to the 3, well, what we can do is we can just simply simplify that by going log base 2, because they're both the same bases, and you go 9 divided by 3, because the subtraction means you divide the 9 and the 3. So therefore, log base 2, 9 divided by 3 is going to be 3, so you get log base 2 to the 3. Now what I want you to do is press pause and attempt the following questions. That is for part A, log base 4 30 minus log base 4 to 6. And for part B, log base 10 2 plus log base 10 15 minus log base 10 to the 6. Remember when you're done to press play so you can check your answers out against mine. So welcome back. Now as you can see we've got log base 4 30 minus log base 4 6. So of course because we've got the same bases here and here, what we can do is just write that as log base 4 30 divided by 6. Now 30 divided by 6 is 5, so the answer is a log base 4 to the 5. Now for part B we've got log base 10 2 plus log base 10 15 minus log base 10 6. So of course we've got all the same bases here, so it means we can simplify it. And to do that we're going to just work our way across. So we do log base 10 2 plus log base 10 15. We do 2 times 15 is just going to be there, minus log base 10 6. Now 2 times 15 is 30, so you get log base 10 30 minus log base 10 6. Now to simplify this we can obviously go, because it's a minus, you do a log base 10 30 divided by 6, grabbing this 30 and the 6 and putting it as a fraction here, and 30 divided by 6 is 5, so our answer is a log base 10 to the 5.